Hey students, welcome back to another video lesson. In this lesson, we're going to study section 1.4 in your textbook, and we're going to start talking about polygons and specifically perimeter and area of polygons. So we have to remember what a polygon is. So here's a few things for you. Okay, recall that a polygon is a two-dimensional object. It is closed, and it's made up of straight sides. Okay. So for example, we have this beautiful triangle, and yes, it is a polygon. Okay, it's two-dimensional, it's closed, and it's made up of straight sides. Here's a quadrilateral that is also a polygon. Here's another shape that's a polygon. And this shape that's been sitting quietly over here, that is also a polygon. So what are some two-dimensional shapes that are not polygons? Okay, what are the ones that break the one or more of those rules? So that shape is obviously not a polygon. Why? Because it is not closed. It is an open shape. And then finally, this shape, is this a polygon or not a polygon? This is not a polygon. Why? Because it doesn't have all straight sides. This side is curved. And in Algebra 1, you did a very nice study of some cool, really cool curved shapes like parabolas and other shapes. And we will study some curved shapes like circles, but most of the time in this course, we're going to be studying polygons, okay? Shapes that are composed of straight sides. Okay, here's some other things that you need to remember about polygons. Okay, you need to remember the sides and the vertices, how to name polygons, and how to classify polygons. Okay, so in this diagram, we have this polygon, and the sides are these sides, the line segments. Okay, so each one of these line segments is a side. So how many sides are there? 1, 2, 3, 4, 5. Okay, so this polygon has 5 sides. Each one of these corners or these angles, okay, is a vertex. Okay, and the plural of vertex is vertices. So this polygon has 5 sides and 5 vertices. We name this polygon, the nomenclature of this polygon is, the convention is you start with any one of these vertices. It doesn't matter where you start. Okay, I could start with C, and then you just name the vertices consecutively. So I could call this polygon, polygon C, D, E, A, B, okay? Down here, I chose to start at A because it just makes it easier, and you could call this polygon A, B, C, D, E, okay? As long as you're naming the vertices consecutively, that's fine. Now, conventionally, we typically go clockwise. Technically, you could go counterclockwise. So you could call this polygon AEDCB, but the convention is just go clockwise. Now, what you cannot do is you cannot skip vertices when you're naming it. You could not call this polygon A, C, E, B, D. No, you can't do that. You have to go consecutively, okay? Finally, we classify polygons by the number of sides, okay? Here's some classifications. So a 3-sided polygon, you know, is a triangle, 4-sided quadrilateral, 5-sided pentagon, then hexagon, heptagon, octagon, nonagon, decagon. We skip 11, I'm not sure why, but a 12-sided polygon is a dodecagon. Does anyone know what an 11-sided polygon is called? Do you remember that from previous math courses? It is a hendecagon, okay? All right, now when we get above 12, when we get, really large, let's say we have like a 27-sided shape, right? Then we're just gonna call it by whatever n is, okay? So for example, what would we call a polygon with 14 sides, okay? We would just call it a 14gon, okay? Just write this word 14gon. Now, if you really want to know what a 14gon is called, we call it a tetradecagon. Bet you didn't know that one. Maybe you did, I don't know. But for this class, you can just call it a 14gon. Now, do you have to memorize all these? Yes and no. So yes, it's a good idea to memorize them because I know that in some of the homework problems, they refer to like a dodecagon or a decagon. Remember that deca means 10. And dodecagon is one that tends to show up on homework problems. So yeah, I would say probably memorize these, okay? But beyond that, you don't have to memorize anything. Just call it an n-gon, where n is the number of sides. Okay. Some other things you have to remember about polygons, the interior versus the exterior. So if I have this polygon right here, okay, the interior of it is this sort of yellow shaded region, the region that's inside of the polygon. And then everything that's outside of the polygon is the exterior, okay? Another term you have to remember is convex versus concave. Convex versus concave. And I'll give you a second to recall what convex versus concave means. Okay. If you're like me and you sometimes get confused between convex and concave, that's perfectly all right. I will give you a little mnemonic to help you remember what is convex versus concave. Okay. First, let me give you the textbook definition. So with a convex polygon, no line that contains a side of the polygon also contains a point of the interior of the polygon. So no line that contains a side also contains a point of the interior of the polygon. So let me just show you visually what that looks like. Okay, so here we have a nice quadrilateral. And if you extend the sides to make the lines, okay, that capture each one of the sides, these red lines, none of these red lines hit any point inside of the polygon. Okay, so that is called convex versus a concave polygon. Okay, so now you have this polygon, and when you extend this side right here, you can see that the red line hits the interior. Also, if you were to extend this line here, that would also hit the interior. So by textbook definition, this is concave. Now, the kind of mnemonic that is not a textbook definition that I use to remember what concavity means is this word cave. One or more of the sides of the polygon is caved in, inside of itself, right? So it's caved in. It's like there was a side here and then something happened and it got dented in or caved in, okay? Like this star, okay? This is caved in. It's caved in. So not, again, a mathematical way to think about it, but just a little mnemonic that might help you, okay? Also, you need to recall what regular versus irregular is, and I think that everyone recalls with a regular polygon, regular polygons have all of its interior angles are congruent and all of its sides are congruent. That's for regular. Irregular means one or both of these are not true, okay? So for example, here's a regular polygon, okay, the simplest polygon of all, a triangle, okay, and then here is an irregular polygon. Now this looks very nicely symmetric in a lot of ways, but it's irregular. Why is it irregular? Because not all of the interior angles are congruent and not all of the sides are congruent. You can clearly see that this side is longer than this side. Okay. Now what are these little black marks that I put on when I was making this triangle? Those are congruence marks, okay? And also you will see congruence marks in the interior angles as well, which will look like little arcs, okay? Don't worry about that. We'll talk more about that later on. Okay, so let's get to the business of measuring polygons, perimeter and area, okay? So perimeter. Perimeter is, as you recall, perimeter is like the distance traveled around the outside of the polygon. Now, that's not a textbook definition, but that's kind of a nice mnemonic, a nice memory device to remember what perimeter actually is. Like if you're walking around the outside of a polygon and you go all the way around it, okay, how far have you traveled? Okay, and how would you calculate that? You just take the sum of the lengths of each one of the sides. Okay, super easy. So like this, if you have this polygon here, first of all, is this polygon convex or concave? Well, this side is caved in, so this is concave. Now, in this course, we're really not going to be studying concave polygons. 99.9% of our study in geometry is going to be on convex polygons. Convex polygons just have some really nice features. They behave very nicely. They're really easy to do some calculations. These things get a little bit tough to do calculations on. But perimeter is an easy calculation. So perimeter, what do? You are given all these side lengths. You just add them all up. So P, capital perimeter, or capital P, meaning perimeter, is equal to 5 plus 4 plus 6 plus 8 plus 9, which is equal to 32. And don't forget your units. Since these all have units of meters, the perimeter is 32 meters. Now, this is a unit of measurement. Meters is a one-dimensional measurement. Okay, we're measuring in one direction. Okay, so one way to think of perimeter is if I were to take off each one of these line segments and line them up, okay, remember back in a previous lesson we talked about the segment addition postulate. So if you kind of use that thinking of adding these segments together to make one really long segment, okay, perimeter is like, well, how long would that one line segment be if it was one line segment that was, made up of all these sides? Okay, and that also helps you visualize why perimeter is a one-dimensional measurement. We're only measuring in one direction. Okay, next is area of a polygon. Okay, area of a polygon. So the way that I like you guys to remember the area of a polygon is the amount of space, the two-dimensional space that an object takes up. Okay, how much two-dimensional space does a polygon take up? So for example, if you have a desk and your desk represents sort of part of a plane, and you put a sheet of paper on top of the desk, and that sheet of paper is, let's say it's, represents a rectangle, a polygon, how much desk space is being taken up by that two-dimensional polygon, right? How much desk space is that sheet of paper taking up? That is really what the area is, okay? You may have learned, I think some math teachers present area as the space inside of a polygon. Which also is not, mathematically, technically, exactly correct, but that's a nice way to think of it, a good way to think of what the area of a polygon is. Okay, so here we have this beautiful triangle, this nice bright green triangle, and this triangle has a special feature. I put a right angle there, so there's a right triangle, and the space inside is this green region. Okay, and I like to think of it as, well, how much space, how much two-dimensional space is this triangle taking up? Okay, so let's give you some dimensions. Let's say that this side measures 3 feet, and here's another dimension. This side measures 4 feet. Okay, and what is the area of the triangle? Do you guys remember? Area of a triangle is 1/2 base times height. Okay, 1/2 base times height. Area of a triangle is equal to 1/2 base times height. And the way to visualize this is that if I just made this into a rectangle, that was a 3x4 rectangle, okay, that would just be double the area of this triangle, right? So the area of the rectangle would be 3 times 4 or 12, and this is just half of that. Well, anyways, area of a triangle, I think we all remember, is 1/2 base times height. Okay, and just be careful. Now, any of these sides can be the base. You just have to remember that the height is the perpendicular height to the base. So with a triangle, it doesn't matter which side you choose as the base. Just remember that this dimension, the height, has to be perpendicular to the base. Okay, so I went ahead and substituted in the values. Area is 1/2 times 3 times 4, which is 1/2 of 12, which is 6. Now, this feet squared, remember that area is a two-dimensional measurement. Okay, we're measuring now in two directions. We're measuring the length as well as the width. Okay. Okay. So here's just kind of a summary, and we're just going to stick to 3 really basic polygons. Later on in chapter 7, we're going to deep dive into polygons. We're going to, calculate areas of, pentagons and octagons and, all sorts of things. We're going to generalize a formula for all n-gons, all regular n-gons. But right now, we're just going to stick to triangles, squares, and rectangles. So for triangles, the perimeter is just a plus b plus c. The area is 1/2 base times height. Now, this is what I'm talking about, okay? If you choose b as the base, that's fine. You can choose a, b, or c, but the height, this dimension has to be perpendicular to whichever side you choose as the base, okay? With a square, we know that all 4 of these sides are congruent. So this is s, 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 s. So perimeter is s plus s plus s plus s, or 4s. The area is just s times s, which is s squared. Rectangle, It's typical to call this the length and this the width, but it doesn't matter. These are just numbers. Okay, L and W just represent numbers. Remember that this would also be L and this dimension would also be W. So the perimeter is L plus W plus L plus W, or 2L plus 2W. The area is just length times width, okay, or base times height. Doesn't matter how you think of it, okay. Fun fact, a square is actually a rectangle, okay? But are all rectangles squares? Not necessarily. And don't worry if that kind of went over your head. We're going to deep dive into that later on, okay? So that is all you really need to remember. I'm not really teaching you anything brand new. I'm just having you draw upon your previous, what you learned in the past, okay? But now we're going to practice this on the coordinate plane. So now when we do our calculations, we're going to do these calculations on the coordinate plane. So instead of just me telling you what all these dimensions are, what L is and what W is, that's too basic. Now, the thing that we're doing to push you beyond what you've already learned is we're going to give you, see these vertices? We're going to give you coordinates for those vertices, and you're going to plot those points and then draw, or sketch, I should say, sketch the polygon on the coordinate plane, then do your calculations. So how are you going to calculate these things? You're going to use some distance formula, okay, which is just Pythagorean theorem, okay, and yeah, let's do some examples. So here are some examples, okay. So first, let's see if you remember what you just learned. Okay, classify each polygon by the number of sides and tell whether it's convex or concave. So in A, how many sides do you see? 1, 2, 3, 4. 4 sides, so it's a quadrilateral, okay, or a fourgon. Okay, and are any of these sides caved in? Yes, so this is concave, right? It's a cool Star Trek symbol. This one, is it concave or convex? Well, this is convex because none of these sides are caved in. And then it has 1, 2, 3, 4, 5, 6. So this is a hexagon. Okay. So in A, it's quadrilateral, concave. In B, it's a hexagon, convex. Okay, easy. So now let's do some measuring examples. Okay. So let me make this bigger. So now let's find the perimeter, not area yet. Area we're going to do next. But first, let's find the perimeter of triangle ABC. Now, you see this little triangle symbol? Triangles are special because they get their own nomenclature. They get their own symbol. Okay, so you read this statement, triangle ABC. And so remember that A, B, and C are the vertices because you name a polygon by its vertices. Okay, so find the perimeter of triangle ABC that has vertices A, and the coordinates are -2, 3, B, 3, -3, and C at -2, -3. So the first thing you have to do is you have to plot these points, okay? And it helps if you actually have graph paper, okay? But go ahead and plot the points, and then connect the dots. Use a straight edge. Do your work nice and neatly, okay? Make sure you label the axes, scale your axes, that kind of thing, all that good stuff you learned, okay? And then go ahead and draw your triangle. Okay, let me just enlarge this a little bit. Then find the length of each side. Okay, find the length of each side. So this side right here is going to be the one that we're going to use Pythag for. Okay, these two sides, notice that this side is perfectly vertical and this side is perfectly horizontal. So this is actually, we threw you a softball. We gave you a pretty easy problem for your first example. Okay, so for this side AC, you can just use what the textbook calls the ruler postulate. I just call it counting, 1, 2, 3, 4, 5, 6. And then with this perfectly horizontal side, also you can use the ruler postulate. I, again, just call that counting, 1, 2, 3, 4, 5. So this side is 5, this side is 6. This is going to be probably an irrational side because 5 and 6, yeah. We're going to use Pythag here, okay? So AB, okay, so they're starting off with the hardest side, which is this, okay? They're using this distance formula. Again, do not memorize and regurgitate the distance formula. It will not serve you well, okay? Simply use your reasoning to understand that this is 6, this is 5, so this is just going to be the square root, of 6 squared plus 5 squared. 6 squared, 5 squared. And that is equal to root 61, okay? So how long is this hypotenuse? It's the square root of 61, okay? Now, can we simplify root 61? Are there any perfect squares that come out of root 61? No, I don't believe so, okay? So your answer, if you were to give an exact answer, this would be part of your exact answer, okay? Now, this example is obviously from the textbook, and the authors did not say to estimate the perimeter. They said find the perimeter. Okay, technically what they should have said is estimate the perimeter, because what the textbook is going to do is, oh my goodness, what did they do? They approximated root 61 to 2 decimal places, 7.81, which cringe. Every math teacher is cringing right now because we do not like to approximate if we don't have to. Okay. Side BC, again, use what the book calls a ruler postulate, just count, okay? And then side CA, okay, again, just count, okay? So what do? You just add these three dimensions together. So 5 plus 6 is 11 plus root 61. So the answer that I would like to see is 11 plus root 61 units. Okay, but what the book is going to do is they're going to estimate the answer. So they're going to do 6 plus 5 plus 7.81, and they're going to approximate that to 18.81. Okay, so look at their answer. So the perimeter of triangle ABC is about 18.81 units. And look at that, they did add the word units. So good for the authors. Sometimes I believe they leave that off. Shame, shame. But at least they said is about. Okay. Okay, let's go to another example. All right, so now that was so much fun. Let's make it a little bit more complex. Let's calculate the area. And I'm sorry this is so tiny, but hopefully you can see this. Can I make it bigger? No. Okay, well, let's find the area of triangle DEF, okay, with vertices D, E, F, and they give you the coordinates. So step one is draw the triangle in the coordinate plane, plot the vertices, and connect them. So now I'm going to make it bigger. So you first have to draw your diagram, okay? Make sure you label and scale your axes, okay? Label and scale your points. Now, this is very important, okay? Your math teachers may not have been a stickler, but I am a stickler. Make sure when you draw a diagram, okay, in the coordinate plane, you label each one of these points with its name, which is D, E, and F, and also the coordinates, okay? You must label each point just like this for full credit. Okay, if you just put D, E, and F, I will not give you full credit, okay? I insist that you actually put what the coordinates are there, okay, and you'll get full credit, okay? Okay, now we have to find the area. Remember that what we're trying to do is find the area of this triangle. So the area of a triangle is 1/2 base times height. So we have to find the dimensions of the base, and it's going to be easiest just to use this as the base because it's perfectly horizontal. And then the height, remember, is perpendicular to that. So if you look right here, we can actually just count for the height. Okay, we don't have to do any calculations. So this is another kind of softball example. Okay, so the base is sitting right here. Okay, so use the counting method. They call it the ruler postulate. So 1, 2, 3, 4, 5, 6, 7, 8. So the base is equal to 8 units. Okay, and then now the height, okay, they say just go ahead and count. Okay, just count. Okay, it is 1, 2, 3, 4, 5, 6. We know that vertical is perpendicular to horizontal. So we know that the height of this triangle is exactly 6 units. Okay, and they figured it out as well. So what is the area? Area is 1/2 base times height. Okay, substitute in the values, and we find that the area of triangle DEF is 24. Now remember, it's squared units, 2-dimensional units. Okay, awesome. So that is all I have for you. I think you'll find the homework fun and easy. So enjoy your homework. It is page 34, 3 through 24. Thanks, guys. See you in the next video.